Hola amigos, ¿qué tal? Estamos acá, nueva edición de Descentralizados en LABitConf 2018. Nos encontramos con un grande, con Adam Back, el padre de Hashchash, que es una de las tecnologías en las cuales se basó el white paper de Satoshi Nakamoto, creador de Bitcoin, criptógrafo con una larga trayectoria en seguridad y tecnologías de la información, que hoy con su empresa Blockstream se dedica al desarrollo de tecnologías basadas en Bitcoin. Welcome Adam to Descentralizados. Thank you so much for being with us.
No, thanks for inviting me.
Yeah, Adam, I would like to talk so people get to know you. Hashchash you're the father of Hashchash. You know, you created it. Why did you create this? And if you can explain in some small words, you know, like what does this mean for you and what it contributed to the ecosystem?
Yeah, so the reason I created it is I was running a remailer, so a way to send private emails. So sort of anonymous email to other people or to Usenet, which is a distributed discussion forum. And I could see that people were spamming through the remailer to try and, because they didn't, some people we think didn't like privacy, so they were trying to create problems by making a lot of messages on Usenet. And spammers, yeah, but like the message didn't have any content. It's just random text basically. So we thought that, okay, they don't like privacy, so they're trying to spam, so the system administrators would complain about the remailer and shut it down or something like that. So I was thinking, okay, well, you know, how can we reduce the spam problem and fix the problem? And so normally when people do anti-spam things, they're often thinking about, oh, who's the sender, and let's block this person or censor this person. And even today, that's still the way a lot of anti-spam things work, right? There's like blacklists for internet machines. That IP address is blacklisted, or this email address is suspected to be spamming. So because it's a remailer and it's providing anonymity, you can't do that. And I think that's a bad thing anyway, right, to censor people. So then I start to think, okay, what's the real problem is that email is free, so we need to make it cost.
So you started thinking outside the box.
Yeah, so like, okay, firstly, what's the real problem? Like, don't keep playing with identity. It's bad for privacy and it doesn't really work. You know, people keep spamming, they can make new identities, so it's kind of a waste of time. And it doesn't really solve the actual problem, which is it's free, so people are going to send lots of them. Yeah. If they can make, you know, 1 in a million, they can make $1, they're going to send millions of emails. So that's why I thought about cost. And then, so it's easier, it turns out it's easier to, you know, if you had an electronic cash system, okay, then you could charge a small, like 1 cent or something for a message, and that would be one way to solve the problem. But there was no electronic cash system, and it's much harder to scale an electronic cash system. So I looked for a way to create a cost, and you can create a cost without having a reusable electronic cash system with this proof of work concept.
So you made them pay in a different way.
Yeah. So I mean, they paid a cost, but nobody received the value, apart from reducing the spam for everybody, which is a different kind of value.
Yeah. Okay, but that worked out great, and it was a basis for a very cool technology that we are now all gathering around. That was Bitcoin. You know, I was listening to your talk, and you tell, if I listened correctly, that Satoshi Nakamoto contacted you before he released the white paper. Yeah. Can you tell us a little about that backstory? You know?
Yeah. So I got an email from him in August 2008, and he was asking about the correct citation for the Hashchash paper. And I also suggested to him to look at B-Money, which was another proposal by Weidai, which was a sort of Bitcoin-like idea to make a distributed network where you would mine coins using Hashchash. And so the problem that B-Money had was it wasn't so clear how to decide how many coins should be created. Like how much work should it take to make a coin, how many coins should there be? So it was kind of left to some servers to decide or something. So it's not as decentralized. And Nick Szabo had another system called BitGold, which was sort of similar. His idea was that you let people make as many stamps, like proof of works, as they want, and then you have a market where people try to collect different scarcity stamps and make a standardized value, with the assumption that rare stamps should be more expensive, but you could, you know, put together a collection of stamps and make a standardized value. So there's a type of market called a collectible market. So that was his proposed way to deal with this. But so those weren't very satisfactory or good solutions. So I think that's one of the things that Bitcoin managed to do, was to simplify that and make it automated, so that there's no human judgment or kind of specialized market for
arbitrary things.
Yeah.
Perfect. Going a little back, you're a cryptographer. What motivated you to go into that direction? When you were younger and decided what to do with your life. You could be a painter, you could be whatever, but you decided to be a cryptographer. What motivated you?
So I became aware of RSA encryption. A friend of mine at university was doing a project to make it faster using lots of CPUs, because it's quite CPU expensive. Computers were slower then. And a little while after that, PGP came out, and I was very interested in the fact that PGP could change the balance of power, right? So, an individual, quite powerless person in the world can send an encrypted message to a friend across the world, and there's nothing anybody can do about it, the government or, So the idea that you can use technology to improve individual control or liberty, privacy, was very interesting to me. So I got interested in more encryption and things you could do with encryption and cryptography. So that was the kind of motivation about privacy and individual control. And of course, one of the biggest sort of holy grail applications for cryptography was to make a working electronic cash system that had privacy and sort of bearer control. So you'd have the money like a physical coin, and nobody could take it.
Basically, giving back the power to the people.
Yeah, that kind of thing. Yeah.
So moving forward, in your history, now your company is Blockstream,
Yeah.
and you are developing Bitcoin-related solutions and second layer solutions.
Yeah.
Can you speak a little about your company and what your current projects and?
Yeah, so we work on a few different direct Bitcoin and layer 2 Bitcoin things. So we have a Bitcoin wallet called Green Address, which has been around for a number of years and provides multi-signature and hardware wallet support. And we also work on Lightning. So one of the Lightning implementations is C-Lightning, is done by some people at Blockstream. And we participate with the open specification for Lightning for interoperability between the implementations. And the other thing we do with layer 2 is sidechain. So we have the Liquid sidechain, which is kind of, it's like another blockchain, but it doesn't have its own currency. Its currency is Bitcoin. So to use it, you can move Bitcoins into the sidechain and use them and then move them out. And so Liquid itself is designed for traders. So people who trade on exchanges, with the idea that it can improve security and privacy from analysis of what they're trading and what price and things like that. So it's a federated chain, so there are a set of servers that are signing transactions, and so to the Bitcoin network it looks like a big multi-signature, but it's its own chain with its own rules, and it has a number of interesting new features like confidential transactions, which encrypts all the values of the transactions. So somebody, you can run a full node to validate the chain is operating correctly, but you don't know how much, how many coins are transferring, so there's better privacy.
Perfect. And you also have a satellite, right?
Yep.
What was the idea behind that? Because it sounds very cool to have your own satellite, it sounds fancy, but what was the main idea behind that, the ideology behind that?
So actually it's done with leased bandwidth, so we leased a small bandwidth allocation on 4 satellites, and the idea is that it's important for Bitcoin security and to have actual bearer control of your assets without trusting other people to be able to run a full node. And running a full node is somewhat expensive, like it uses quite a lot of bandwidth. Yes. And so we thought, well, if we can make a cheaper way for people to receive the Bitcoin transaction data and the blocks, it can reduce the cost of participating and allow more people to participate directly. So we used a standard satellite dish, like a 45 centimeter dish, and we reduced the cost by using a software-defined radio. So it's like a small USB drive thing that does analog to digital conversion, and then the signal processing is done on a laptop or something like that. So it means that the specific parts are, maybe $100 less if you can reuse a satellite that's not used, like a satellite dish from satellite TV. So really the idea is to enable more people to directly participate in the Bitcoin network. And it's also, it's good for privacy because if you're running a Bitcoin node, your ISP can see the traffic, right? So the satellite's broadcast, so nobody really knows you're using it because it's sort of receive only. There's nothing to monitor to see who's using it, kind of thing.
Yeah, it sounds like a very clever idea. What's the actual coverage, of the satellite?
So it's at the moment it's providing about 2/3 coverage, but we're going to announce further coverage soon, so that we'll have almost global coverage after that.
Okay, so you plan to extend the coverage?
Yeah.
Awesome, awesome. I also read it like a few weeks ago about the release of a new scripted language that you're releasing called Simplicity.
Right.
Can you tell the people about what Simplicity about, in a few sentences, so they can understand this new language?
Yeah, so it's a low-level language, so it's kind of like assembly-level language in a way, and it's using a similar model to Bitcoin. So it's it has a limited state. So with Bitcoin, the contracts are really predicates or simple rules that you have to satisfy to spend an individual coin. So when you decide whether or not this transaction is valid, you only have to look at the coin. You don't have to look at history or some database or anything like that. So it makes it more secure and simple. And what Simplicity does is it extends that concept with this low-level language, which is designed to be formally verifiable, so you can make assurances about the correctness of the program, that it will do the right thing in all possible eventualities. And also you can make predictions about its runtime. So it's not Turing complete, but it gives you the same power as Turing completeness. And the reason it can do that is because you're not executing the program, you're verifying evidence that the program ran correctly. So it's sort of a proof of program execution that you verify instead of being the actual execution. And that means you can prove to the recipient and to yourself, okay, it will take no more than this many resources like memory or CPU to verify.
Okay, that's very cool. To wrap it up, I will really like that if you can give some advice or some word of encouragement, if you like, to new developers joining the space, maybe from another technologies, or people wanting to go into mathematics, into cryptography, people that are going to be very useful to this ecosystem. If you have a message for them, encouragement or discouragement, whatever you have, just go for it.
Well, I mean, I think it's the most interesting space for me personally because it has everything, right? So, it has some cryptography, some peer-to-peer networking, some game theory, which is, the complicated game of it being the most profitable thing for somebody to behave correctly. And the consensus algorithms are also quite interesting. And there's a lot of focus on security and correctness and testing in the code. So if people are interested in any of those things, from a computer science or programming background, or even to explain to people or write documentation, things like that, it's a very interesting area. And I think that it's a very positive impact for society in general. So that's what makes it interesting to me.
I think so too. Thank you so much, Adam, for being with us. We're very happy with this. Chicos, esta ha sido la entrevista con Adam Back, un grande de la criptografía, el desarrollo de esta tecnología. Muchas gracias por estar con nosotros. Nos vemos. Estamos acá en Descentralizados en LABitConf 2018.
So, thank you.